Well, welcome everyone. Welcome to this session called The Art and Joy of Testing in Production. Almost one of the last talks at NDC Oslo. Hopefully you had a great time up until this far. It's my second time at NDC Oslo, although this time is very different from last year when I was here for the first time. I really think the organization did a great job moving this to a online format. I think they did a really good job of making this an actual event instead of just joining some random session. So really props to them. Thanks uh, for hosting me. Really grateful to be here. I was really excited when I got the invite to speak at NDC Oslo again. Was really nervous to go on those hanging stages and speak there. But well, everything has changed. So now I'm here talking to you from my home in the Netherlands. So hopefully you'll have a good time. You already had a good time. Let's make this session the best. Let me quickly introduce myself. So why am I talking to you? My name is Geert van Cruijsen. I'm from the Netherlands, where I work for a company called Xspirit. We're a consulting company helping other companies build better software, basically. So that's what I do in my role. I often act as a DevOps coach, a software architect, or a cloud architect. And I really like to combine all these three areas to help teams build better software. And testing and production is something that really combines all these different areas. So that's why I love talking about this subject and also helping my customers move towards something testing and production. So let's get going with the content, right? Testing and production. When we build software as developers, we love building software, but for who are we building our software? We're building our software for our end users, right? And where do our end users live? They live in production. So in the end, all that matters is how is your application running in production? It doesn't matter that your application is running on your dev machine. It works on my machine. It doesn't matter if it's working on staging. No, production environment is the only environment that actually brings value to the table. So if you look at your current applications that you're building and running, how do you know that the production environment of that application is actually working? Please take an application in mind that you are currently working on or recently worked on. How do you know that application is currently delivering value to your end users? Do you know it is up? Do you know it's working? And how do you know? Do you know because you've built a number of dashboards that show you all green blocks, so nothing is wrong? And if so, if everything on the dashboard is green, does that mean your application is fully working, or can there be stuff that your dashboard is not catching? Can it be that you live on alerts? So, oh, I don't get any alerts. My application is working fine. My users are not in trouble. How do you know that your alerts are working? How do you know your users are actually being able to use your application in production? It's really hard to actually know this. And a lot of the companies and people I talk to, they use this well-known method of knowing that your application is working in production by just waiting till the phone rings with angry users, uh, well, complaining that stuff is wrong. So what we're going to look at today is, can we create an approach that we can actually know that our application is working on production? Because we don't want our end users to be the guinea pigs that are using our application, but also are the only ones testing our application, right? So knowing that our application is actually working currently in production is really important. Then next to running an application in production, deploying new changes to production is often, well, a really large risk of breaking production, right? So please think about one of the last deployments you did, maybe this morning, maybe yesterday, last week, last month, a couple of months ago. I hope that the deployment wasn't too long ago. That already explains a bit to me that you're a bit more mature in releasing early and often. But the most important thing is, and it doesn't matter how often you deploy or when the last time was, is how did you make sure that before you sent that new version to production, how did you make sure that it was safe for your end users? How did you make sure that it was safe and it would not break for your end users? When I ask this to my customers, the most common answer is, well, we deployed to staging first and we tested everything on staging. That was all fine. So there's no risk anymore on production, right? Well, today I want to talk to you about staging and what I really dislike about staging environments. I think staging environments are something that we tend to use, but should be something for the past. I think with the current technology, current tools that we use, there are better ways to test these things and not rely on a staging environment. So let's go over some of the really big problems that staging environments have. First one and the biggest one is staging environments give you really a false sense of trust of the quality of your application. When I ask people, is your staging environment equal to production? They say, well, we spend a lot of time and effort to actually making our staging environment be the same as production. So is your staging environment really equal to production? Really, is it equal? And there's a number of things you could check. First thing is, does your staging environment has real data? I often come to companies and they have all kinds of exports of data from production going to staging, anonymizing this data. But still, even if you go through all this trouble, does it contain all the data from production? Does it contain those outliers? Does it contain those weird cases that were there because of production being migrated through all kinds of different versions in the past? Does it contain the data that didn't really work through validation or was filtered out in production because of validation? Those kind of data inputs you want to have as well. Does your staging environment have the same complexity as your production environment? Or is it only a small subset of the features that your production environment has? It might appear that two components in the same architecture are not connected to each other, but if they run on the same infrastructure, they could affect each other by one process using more CPU, slowing down the other process. And our applications are becoming more and more complex. So creating this full complexity in a copy of environment is becoming more and more unrealistic. Then do we have real users? Real users do stupid things. But do we also have users that have the full history of actual users in production? Well, it could be that these users are clients for you for 10 years and they have so many things they went through with data migrations and all those kind of things. Is that equally the same on a staging environment? Then looking at load, is the load on a certain system the same on staging compared to production? Often we do load tests, for example, but we only load test a specific area of our environment, and it could be that other parts of our environment actually impact the rest of the staging environment or the production environment. Then are we running on the same infrastructure? Does it have the same scale? Does it have the same network? Does it have the same configuration? It's so hard to actually create a really equal environment in staging compared to production that I really don't believe that it's equal enough to say there's no risk anymore. And lastly, as I already said, do you know your alerts are working? Do you have the same kind of alerts and monitoring on your staging environment to see what is going on that environment? And what we have to take into account with these more and more complex applications is that we're living in a world now where I think we can't be sure that our full application landscape is fully up. We just have to be conscious that our application will never be fully up. That's the world we live in right now. We're building applications using the cloud, microservices, all kinds of technologies that make your application communicate over the network through all different dependencies. If you use a database, that database is somewhere on the network. When you use a cache, it's somewhere on the network. You configure your own ingress. You use some functions, queues. Everything is running somewhere on the network, which is really unreliable. I like to think about our applications becoming more and more like the power grid of a certain city. It could happen, it always happens that some part of the electricity grid is not working somewhere in the city. There's always a light bulb or a street light that's not working at a certain point in the city. But in general, the grid is working and most of the users are not impacted. So maybe only the person that's living in the house next to the street light is impacted. But we want to make sure that we can pinpoint those areas and make sure when our application fails, it fails in the smallest way possible. So with that, I think moving to a system where we focus on trusting our production environment is more important than focusing on a staging environment. We can make sure that everything works perfectly on acceptance, but how do we test all these outliers? It could be that the database is not accessible for a certain moment of time. Can we test that in our acceptance environment as well? I would rather focus on MTTR, mean time to recover or mean time to repair. So when stuff happens, we can actually roll that out really fast to production so we can fix these small issues and focus on our users not being impacted. The second thing why I think staging is not that good is staging is really expensive. Staging environments can be really expensive. I've worked at companies like banks or companies that worked with medical systems, and they went to great lengths into creating a really complex staging environment. And actually, when we try to calculate the cost of these staging environments, it could cost up to 30% of the total cost of the software development project. When I first heard 30%, I was like, no way, how is that possible? But when you take everything into account that happens, it's actually so many stuff that people go to so great lengths to actually create this really complex acceptance environment or staging environment with production like infrastructure, production like data that has to be anonymized, because when you're working with medical information or bank accounts, you don't want all your testers to be accessing the production data. So there's really expensive tools and processes to anonymize this data day after day. Full teams working on syncing all these applications because all the applications need to be anonymized, working together. Yeah, I'm hurting your old staging environments feelings. Yeah, I've seen so many teams struggling with all these things, all these processes in working with staging, and it just costs too much time and effort. And if you look at your time, I think that's even the most important part, right? You could have enough money to spend on really expensive staging environments, but you as a development team only have so much time that you can work on your projects, right? So if you spend more time on your staging environment, it means you spend less time on making your production environment better or making your production environment more resilient to failure. So I rather have you spend time on building your software in a better way and having it run on production than spending it on areas of, well, a staging environment that doesn't add any value to your end users. The third biggest point of why I don't like staging environments is they create a natural handover point to, well, you as a developer, you deploy your application to a staging environment, and then someone else takes over, right? That's something I see happening over and over again. And I really like the mantra of DevOps: you build it, you run it. So as a team, you're responsible for building your application and running it in production. Uh, This term, initially coined by Werner Vogel, CTO of Amazon, I think it really, well, it really resonates with me, right? If you're responsible for building your application and running it in production, you also take into account that quality and resilience are really important points. I often see product owners, for example, and those product owners are only responsible for pushing out new features. I think product owners or product managers should be able to focus on everything, so they should be responsible for the whole application: its features, its security, its resilience, but also its cost for example, the infrastructure it's running on. If we're responsible for all of these areas together, you can make the right decisions of where should we focus on. Should we focus on new features, or should we focus on making our application more stable on production? And then the last thing I want to mention about staging environments is staging environments just tend to be a bottleneck in the release process, right? As a developer, you deploy to your staging environment, and then often someone else takes over. They start to test, do some acceptance tests, those kind of things. And as a developer, you start working on new features. And then this tester or person who is verifying all the changes, they find some issues. You have to make context switches again. You have to switch environments, all those things. It just takes a lot of time and effort. So let's move away from this. So my idea is, let's move away from staging and move towards production. Right? When I mention this, often for the first time to customers, they look at me like I'm this guy in this meme, right? So, okay, so you want to test in production. Isn't that a bit reckless? Well, in my opinion, it's not that. We want to be testing in production, but it's only an addition of what we currently do. It's only an addition to all the tests and all the verifying that we already do, but it's a really valuable addition to what we do. So in the rest of the presentation, let's look at how are we going to do this? Where should we start with testing in production? First thing is verifying in production, knowing that your application is actually working. And then the second part is, how can we change our view on testing so we take production into account as well? First thing, verifying in production. When I talk about verifying in production, we want to check that the application is actually running in production. We want to know this anyways, right? So even if you would keep your staging environment, we still want to know that our application is actually running in production. So with or without staging environment, it doesn't matter. We want to know that our application is at this moment is working and is delivering value to our end customers. So what we need to do is basically focus on two things. First, measure how users are impacted. And the second one is verifying how business processes are still, if they are still working. Can certain processes still function as we expected it to do? So for that, I have two examples of recent projects that I worked on where we try to verify in production, and I'll talk you through these examples. First off was a service that we built as a team that worked with two different applications. They were both black boxes, so we couldn't add any code to these services. But the first service was, or the first application was an application that was being used by end users, and they were administrating users in that system. And we needed to create a system that would synchronize these users towards a second application. So from there on, it could be used, those identities could be used in other applications. So we created this process in the middle, and of course it outputted certain log files, and we could get some logs from the second application when we called those APIs as well, and we could create alerts on if our processes were failing or if they were succeeding correctly. But did this actually prove that these users are being synchronized from the first service to the second one? You don't know, right? You don't get any error messages. You assume everything is all right. So what we did is we created a second process that would constantly keep on adding a new user in the first system. So just acting as a normal user would, it would add that user asynchronously. Our process that we created in the middle would pick up these changes, would synchronize them to the second system, and this process on the left here would then check to see if this user already existed in the system number 2. And as soon as it exists, it starts deleting this user and checking if the user is actually deleting in the second system, creating it again in the first system. So this way we kept on checking all the time our full business process, and our application was keeping up with all these changes. And with the log files of these 3 applications together, we could actually start measuring how long does it take for us to enter a user in the first system until how long it takes to show up in the second system. We can't know if we only measure it in the center part, because we don't know when it was added in the first system. Now when we add something in front of it, we actually know when a record was created, so we have the full length of adding the user to show it's showing up in the second system. And with that, we could measure our service level objective. We had an objective that users needed to be in a second system within a X time period, a number of seconds. And with constantly doing this, we knew what was the time that it took from inserting a user and it showing up in the second system. This is really valuable, and we could have alerts of, hey, we created this user, but it didn't show up in the second system within a couple of minutes. Okay, our application is down, or maybe something with system 1 happened. This gave us a lot of insights of how the process was working. And the second example, focusing on user experience and how our users are being impacted, is an example through a e-commerce website. In an e-commerce website, we log in as a user, we buy stuff, add stuff to our shopping cart, and from there on, the web shop will take us through payment and the order will be shipped, right? What you could do is create some sort of script or bot that just goes over your site and starts buying stuff on your web shop, and just use the same process as an end user would, and then verifying that it can actually buy certain products on your website. Of course, this is a bit more tricky, right? Because if someone buys stuff on your website, it will actually ship stuff somewhere, right? So it might sound quite hard to work around this, but it wasn't too hard. What you could do is have this robot or test script that logs onto your website and buys stuff. We create a new user from a specific domain that we own, our company-test.com. And we control the domain, so we know all the users that use this domain are our test users. So this user logs in to the web shop, buys stuff, and then the only thing that you need to do is really at the last part of your process that actually starts the payment process or actually ships stuff to the end user. In there, you just make a simple if statement. If the end user, if the user has an email address that starts with or ends with company-test.com, then we cancel the full order. And this way, it's really nice that we can just follow the whole process, and we only need to add 2 or 3 lines of code that would just cancel the order for these specific test users. It doesn't impact any of the other users, except of course that this robot will buy stuff on your website. So if you only have one item in stock and this robot would buy it, it could be that this item is actually no longer in stock for other users as long as it stays in the shopping basket of this robot. So yeah, it could impact users in a different way. So you could focus on buying certain products that you know that are always on stock, or work your way around that, right? It's really specific on your case. Another thing is that this bot just behaves as an end user, right? So it actually buys stuff on your website and then the order gets canceled. So if you have like all kinds of measurements of how many sales you did and where people dropped off in the sales funnel, you want to be able to exclude these measurements from the bot, because if it buys stuff on your website every couple of seconds, well, it might affect a lot of the numbers depending on how many people are actually buying stuff on your website. So this is all I want to say about verifying in production. I think when you look at your applications, I think you can come up with ways of, can we create an automated process that actually starts measuring stuff, and is our application working in production or not? It could be that you have to create a number of test accounts in your production environment, but there's not that much harm in that, right? So next to verifying in production, I really think we need to change the way we look at testing. When we look at testing and I talk to people about test automation and those kind of things, they almost always show me this diagram, right? And I think most of the people here know this diagram. The agile testing pyramid, focusing on a really large base of unit tests, covering all the stuff, if our code is working, if the different units of code are working. On top of that, integration tests, UI tests, manual tests. Those tests are all great. I think they should all stay in the same way that you're doing them now, if you're doing them in the right way. But the main problem with this is that all these tests focus on a pre-production environment. Right? We should add other tests here as well that focus more on the production environment. So let's change our view on testing. So we have production testing, or pre-production testing, the testing pyramid that we already have. So don't stop unit testing and those kind of things. We just need to add some more testing. That's testing in production. And when we talk about testing in production, I really like this diagram created by Cindy Sitaran, if I say her name correctly. She created this diagram in one of her blog posts called Testing in Production the Safe Way. And she really describes all the different kind of testing that there is pre-prod, but also in prod. And the nice thing about testing in production is that we should split this up into multiple phases again. So there's 3 different phases of testing in production: deployment test, release test, and post-release test. So when we want to start testing in production, I think one of the most important things is that we actually should start splitting up deploys and releases. So if you want to take away one thing from this talk, it's how can we make sure that deploy and releases are separated? So what's the difference of the difference between deployments and releases? Deployments are deploying a new version of software to our production infrastructure. And then with release, we're moving traffic from our production environment to this newly deployed version. Separating this gives us a lot of flexibility and capability of testing stuff before we expose it to our end users. So with deployments, we focus on how can we deploy without impacting our users. And if we can do that, if we can deploy a new version to our production environment without sending any traffic towards it, we can do a number of tests after this deployment. First of all, we can start doing integration tests. We already do integration tests pre-production to see everything working together, but we could also do this on a production environment. And then when I talk to teams about integration testing, I really want to focus on not doing full end-to-end tests. Integration tests should not be about testing a end-to-end flow. As I said, our applications are becoming more and more complex. Where does your test start and where does it end? When we want to do integration tests, we want to focus on integration between two specific components. So we really have to think about small tests between two components. If these two components are working perfectly together, and then the second service is working together with the third one, we can also make sure that the first one and the whole flow from the first one, second, third will also work. So focusing on contract testing between two services is really important, and it's something you could do on your environment by sending some traffic or running some tests to this newly deployed version and seeing that everything works. The second way of testing these deployed features is using something called tab compare. In tab compare, you have two services deployed or two versions deployed, and then we just copy the calls going to version 1 and send them through some tooling to the second version. And there's different tools that can actually do this, open source tools like Differentia or Diffy, which are all open source and easy to use. You could use these tools and they will look at the traffic going to version 1 in production, send them to the second version as well, and compare the differences between the outcomes of version 1 and version 2. And so if you keep running these for a while, you actually can make sure that the code in version 2 is actually working. Then we have load testing. Normally when I see people do load tests, they often start with nothing and they have a bar that we should be able to reach so many users at the same time, right? We should be able to serve so many requests at the same time. When you're deploying small changes from one component to the other to a new version, you could also start measuring differences in memory usage, speed, etc. of those small service calls. So with that, you can just look at the differences of having two services running at the same time. For example, using the tab compare, doing the same calls to these two services. And when you see that the newer version its response time is slower, or its memory usage or CPU usage is higher than the other one, then you know that gradually you're making your application slower. So this gives you insight of how's my application doing compared to the previous example. If you test a application from end to end doing load testing, it's really hard to see where are my performance differences. And if you just focus on these small areas that you deploy and start measuring what are the differences between these two versions, it gives you a lot more insights of, am I making my application slower? Am I using more resources than before? Or is it actually becoming faster? And then the last type of test I would like to discuss with you in the deploy phase is configuration testing. I've worked on many projects over the years and I've seen a lot of outages over the years. And when I think back of all the outages that I've seen, I think more of the outages that happened after a deployment were often related to configuration compared to actually code changes. Because the code is often tested quite well. We already have the unit test, doing these integration tests, all those things in either your development environment or staging or whatever environment you're using. So we're really focusing on making sure that our code works. But then where is this configuration being used? It's only being used on your production environment. So how do we know that this configuration actually works? When we have this application new version running somewhere in a production environment, it uses the production configuration. So we can actually start firing some requests to it to see if it's actually working. As I said, the verifying in production stage with those robots or scripts that actually test your full flow, you could configure them that these scripts are using the newer versions already. So if you make changes, these things will break and you get insights of your configuration having some issues. So then from deploy, we move into the release stage. And with release, we're focusing on how can we move traffic to our users in a controlled way so we don't expose the new feature to everyone and all our users, but can we control it so we can control the blast radius of things that go wrong? And the first example of this that you probably heard about before is canary releasing. So with canary releasing, what you can do is actually start moving some traffic from version 1 to version 2. For example, move 1% of the traffic to a new version. And with current technology that's becoming more and more popular, like Kubernetes, but especially service meshes like Istio or Linkerd, controlling this network traffic is easier than it ever was before. And really with the mantra of you build it, you run it, we want to be in control of all the different areas of our application. So also being in control of the traffic towards our application. And using those canaries can really help us test with this 1% of the users if this new version is working. But still, we're working with 1% of our users. So 1% of our users is impacted. And what I like about canary releasing is that we can take this a step further in something I like to call focused canaries. So what you could do is instead of taking 1% or a couple of percent of your users, focus which users are actually going to the second version. As we already discussed, we could have these automated processes that test our application, verify if our application is still working. If we send traffic for these scripts first to the new version, they could actually start doing some tests on this new version, giving us some more insights. So, and if we take this further, we move from canary releasing to ring-based deployments. And what I really like about ring-based deployments is that we can have different stages of how many people we expose to certain new features. And we can start with internal testers and then expose the data a bit more towards a larger group of users. All of a sudden I hear a lot of noise. Okay, it's gone again. So what we could do is expose our features to more and more people gradually over time. But then it becomes the question of, okay, how do we expose those rings? Who is in which ring? And I like this example that one of my colleagues had when he was talking to one of our customers. That customer was building charging points for electric vehicles. So this company had charging points all over the Netherlands. So this is a picture of the Netherlands and a schematic value of where these charging points were. And they said, well, we could do gradual deployments to all of these or releases to all of these different charging points. So their initial idea was, let's deploy firstly to all the charging points in a province called Zeeland, which is in the bottom left of the Netherlands. From their idea, it was a good idea to deploy towards these machines because their office was somewhere in the middle there. So when stuff went wrong, they could actually go to the spot and fix it. But What they didn't take into account is actually how this impacts users. Let's say a deployment goes wrong, everyone in the wide area of this province can't charge their car. So you have to actually move to a different province to be able to charge your car. So taking this province as a first ring is really a bad idea. It's better to actually take a random number um, of charge points and deploy to that. So if they wanted to expose to, let's say, 10% of all the charge points, which was equally the same to this province, they could also deploy to all the charge points which serial number ends with the number 9. That's probably a random distribution all over the country, and not impacting users that much because they could just move to the charging point that was right next to the one that was broken. And adding a new ring before that, focusing on all the charging points that were located at their own office, was even a better idea. Let's deploy first to the parking spots of the actual team building this, or the charging point of your CEO's parking space, right? He is paying your salary, so well, if his charging point is broken all the time because of bad deployments, you will start focusing more on the quality of your deployments and releases. So start with really focused releases to certain users so you can make sure that everything works, and then expand it more and more. Coming to the last example of how we can release in a safe way is feature flags. Feature flags give you even more control of how you can release to certain users, because feature flags are basically not that much more than a if statement that you actually ship to production, and then you're able to flip this if statement using configuration changes. Right? So this gives you a lot of control, and it actually gives you the possibility to ship multiple features at the same time and switch them on and off. The problem with canaries or ring-based deployments is that you can only deploy one thing at a time. As long as this canary is still being tested, you can't deploy a new version over it, because how do you know which version is being tested then? Right, so feature flags gives you more control of this. And if you want to know more about these different types of releases, like that I just explained, about feature flags, canary releasing, actually the talk after my talk by Santosh he's going into how you do this through code. So I want to discuss the concepts of why you want to do this, and he will show you some more code examples of how you could actually implement it, but it wouldn't fit in my 1 hour talk. So feature flags also have a bit of a downside, right? If you look at canary releases or ring-based deployments and releases, that doesn't add any technical depth in the end. As soon as a canary is exposed, or you're exposing this new feature to all the users, the canary is actually gone, and you could just start doing new releases. With feature flags, you have this if statement somewhere in your code, and as soon as you have all the users using this new feature, this if statement keeps on existing there. So someday you will have to remove it. And when you use these feature flags extensively, this can build up quite some technical depth of flags somewhere in your code that you need to handle. So that brings us to the last part of testing and production, the post-release phase. At all times, we want to be able to see, are certain users being impacted? And what we tended to do before, in stages before this, is, well, we already had monitoring, right? We had these dashboards of stuff going wrong, or we get some red squares or green squares of stuff being healthy or not healthy. But monitoring focuses on known unknowns. And what that means is we focus on the stuff that we know can go wrong, right? It could be that our server is using 100% CPU, so it's slowing everything down. That's a known unknown. We know that CPU might spike and will impact us. But the unknown is we don't know when it will happen. But with these more and more complex applications and scenarios, we don't know what could go wrong. It can be so many different dependencies going wrong or network traffic between all of our different components. We have to move from monitoring to observability, and observability focuses on unknown unknowns. And what that means is we know our application will go wrong at some point. We don't know what will cause it. We don't know when it will happen. But when users are impacted, we want to be able to measure that, and we want to query our application to see where is it going wrong, and being far more flexible of what our application is doing and why stuff is happening. So observability is really built up about 3 pillars called logs, metrics, and tracing. And using these 3 areas, you can actually start querying how your application is doing in a production environment and start investigating why your application is not working as it's supposed to do. It's too much time to dive deep into all the little details of observability. I did a talk on NDC Oslo last year about observability. So if you want to dive into that deeper, watch that session back. It's still somewhere on YouTube. But this observability gives us the capability of finding issues in production, and after we know that it exists, we can start fixing them. And knowing that our application will often go wrong, we might want to focus on building a resilient application, right? So a lot of people are working with all kinds of resiliency within their applications. Think about retry mechanism or circuit breakers, or kind of things that switch between kind of behavior when certain parts of your applications are not working as it's supposed to do. And the hard part about that is, how do you test that? How do you know that, for example, when our database is down, we created a script or we created our code in this way, it will show cache data until the database comes back up. We could have created this in our code, but how do we actually test this? And chaos engineering is a really nice technology of how we could do this, or method how we could do this. Because what chaos engineering does, it's actually something like a vaccine. We start injecting some harm. So let's say the database is down, then our cache should take over. What chaos engineering does is, okay, let's create an experiment and take this database down, or let's deploy a new version, the version under test, and make sure that this version is not able to talk to the database. So it's actually the same as the database being down. And within this experiment, we can measure that, okay, the cache is actually kicking in. So we could see that this works on production. So we could actually focus on all these different outliers and see that our resiliency measures that we take actually work. Because this is really hard to do with all kinds of tests, because it can be so many side effects of this database being down. It could be all kinds of all kinds of effects that you didn't think about that could also happen. And with chaos engineering, we can learn what happens in these kind of scenarios. So with that, I want to recap and end my presentation. Some things that I really want to have you take home after this session is, please invest in your production environment. Investing in your production environment is worth the money so much more than staging environments. You only can spend your money once and your time, so spend it on production and not staging. I gave you the reasons. You can take them to your manager and talk to how we can actually move towards a testing and production environment. Next to that, we know our application will fail in production. We can't guarantee it. So if we can't guarantee it, let's make sure our process is able to find the issues fast and fix the issues fast. So that comes to the third point, verifying in production. We want to do this anyway. Even if you're not changing your process, you want to create automation that actually checks your application in production. Then we talked about splitting deployments and releases, giving us far more capabilities of doing testing in production. Then one of the last points, working with resiliency in mind. We want to focus on building resilient applications, focusing on building and running our applications. So when we build features, we also take into account resiliency. And I would like to end with, this stuff ain't easy. It might sound easy as I explain it now, but yeah, it's quite a process of changing culture, changing a lot of things in your applications. So I would like to advise, start small, start doing some experiments with some isolated services, see what you can do there, and learn from there, and use that experience in growing this more and more into doing this anywhere. So with that, I really want to thank you all. I would like to open for questions. I just saw some questions coming in while I was doing the recap. So let me quickly read what it states. How would you handle the database when testing in production? If the newly deployed code points to the same database, the current production code wouldn't load testing affected, and integration tests make modification, then they would be seen by users. Yeah, so what I was focusing on there is, if you want to do integration tests, try to focus on two components. You don't have to test all the way through with, for example, your database. Can you test with only a service in front of it and the actual service calling to your database? But yeah, databases make it, state makes it a lot harder to do. There's all kinds of different ways of how you could do these kind of things. You could work with different kinds of database. Maybe you can move a bit more to event sourcing, where you can actually see you store all the changes coming in, and you can actually do some time traveling, reprocessing all the events that come in to create your new state. So let's move to the second question. Chaos engineering is difficult to manage. That can affect real users. Is it possible to isolate that as well? Well, chaos engineering actually works in the same way as you would do these other kind of tests using CANARY releases. Right? We could create a new version and only have specific users go to that version, and then our normal users wouldn't be affected. So if you can control this traffic, for example, using these service meshes, this gives us so many possibilities to do all kinds of testing, being it functional testing with a new version, or doing chaos testing without like deploying a new version, but deploying the same version a second time, and then moving the traffic towards that same version. Okay, the next question. Can we automate tests in staging environment as we control test data, but in production, if we have to automate tests, it won't be possible to use test data and real data as well. I need to reread this question. Can we automate tests in staging environment as we control test data, but in production, if we have to automate tests, it won't be possible to use test data? I don't really know if I understand the question that well, but yeah, when you're testing in production and you're handling data in production, of course, you need to make sure that it doesn't impact data. That's why I said, like in the example of a robot buying stuff on your website, in the end, you need to make sure that these orders are being canceled, so the actual data is being cleaned up.
No, but yeah.
Go ahead. Please explain.
How are you going to handle the authentication? Like for every data to initiate a process, you need authentication or a consent from a real customer. So in case of automation, how would we be using the real data? in case of a banking application.
Yeah, as I said, you could create a actual account for a non-existing person. So I don't say you should test with my bank account if I'm a customer at that bank. No, create a completely new bank account for a non-existing users. Go through the full process of having a fake user in your production environment. At first it sounds a bit silly okay, so we have this account belong to a person that doesn't exist, but and especially for banks, there might be some legal issues regarding this, but depending on the type of application, you could create an account that is owned by you and lives in the production environment that isn't actually an actual user. And so you can you know the password of this user because you created it yourself. You can just authenticate like it would do as an actual user because you are that user. Does that make it a bit more clear?
Yeah, that's clear, but I think in banking application, as you said, it might be some legal issues, so I don't see really fitting well in these kind of application.
Yeah, banking isn't the easiest scenario, and medical. I'm currently working for a medical company that those have a lot of legal issues as well that you have to take into account. But yeah, you have to discover this and check what is possible or what is not possible within this. I think it should be able to. Should be able to do this with a bank as well. If you don't start sending money to real customers and those kind of things, if you just interact with your own accounts only, there shouldn't be that much of a legal issue. Okay, let's move to the following questions. Mean time to recovery is a great concept. Yeah, I think it's a really good measure to have as KPIs. So focusing on how long does it take for us to fix certain issues within production? There's some really good blog posts about those kind of things as well, and books. So yeah, I advise you to read up on those. You mentioned taking out the database, for example. How can we do that without affecting users? I think I already covered that, right? If we can control the traffic and deploy 2 versions of the same service that connect to this database, and only send a specific amount of traffic towards the second service, and it could be exactly the same code, right? With the same configuration talking to the database. We could control the traffic towards the database so that it doesn't work anymore, right? Or we make a configuration change in the second service so the connection string is broken. If we can control the traffic moving towards the second service and it's only our automated process or only internal users, then we can test that these users are impacted, but our real users are not impacted because they are all going through this the first version of your application. More comments on MTTR. How do you handle integration with third parties outside of your organization? Yeah, third parties are actually can make it quite hard, but what I would like to focus on with third parties is, can you make it optional? And because you can't control the stability or resiliency of this third party, right? So you could focus on 2 things. Either one is making it a asynchronous process, and so you can handle this somewhere later on, and the users are not impacted by this third-party integration. And the second one is, can we do without it if it's not responding? Can we make a circuit breaker so we actually move to a different route and take another option? I think we're running out of time. How am I on time? I think it's almost 4. Is this room being used by the next talk?
Yeah, you can use 5 more minutes if you'd like to answer one more question, and then you guys can move it into Slack.
Yeah, so I see one more question. Let's, after that, move into Slack. You can ask me any questions there, or jump on a call with me, or my Twitter handle is on the slide as well. We've actually tried this in our team, e-commerce domain. We call it tracer bullet testing. Read-only requests to external integrations are usually not a problem, but we stop out the external integration points by switching implementation. Yeah, so these based on a custom HTTP header, and those HTTP headers are really a nice way of routing your traffic. So when your tracer bullet, I like the term, tracer bullet is going through your system, each service that it sees this specific HTTP header, knowing it's your test application, it can go to specific versions of your service and testing it that way. So that's a really, really good option. I was about to suggest this too. We call it synthetic transaction testing with a header. Yeah, so more people using these headers. It's a really good way of controlling the traffic, using these headers and knowing where an application should fully go through or use certain stub data. So with that, I really would like to thank you, and hopefully I will see you all again next year in Oslo, in a venue, so we can have a beer together or some other drinks. It was great to be here. I really liked presenting here in Oslo again. Hope to be back next year. So thank you everyone for coming. And if you have any questions, join me on Slack and or ping me on Twitter.